Hello, hi, how are you? Hope you're doing great. My name is Bilal Khalid, and today I'm going to deliver a demo lecture on one of the very interesting topic of TP physics, which is projectile motion. Basically, this topic is related to kinematics in two dimensions, basically. So we'll talk about that stuff. First of all, I will go through some of the objectives that we will cover in this demo lecture. So, first of all, we will understand some of the basic understanding of projectile motion, and then we will talk about different vectors, like what will happen to velocity vector, how acceleration vector will behave, how force will behave in this whole motion. Secondly, we'll talk about some key terms that we have to understand, like which is range, maximum height, and time of flight. Uh, the time period in this demo lecture is not very much, like it's a short demo lecture, so I will not be able to prove the formulas of these terms, like the formula of range, the formula of height. I will just write down the formulas and I will explain I will explain you these formulas. The third point that we will go through is, like, we will try to calculate height and range for different uh, angle projectile. We will set up different angles of a projectile, and we will see how the range and height will differ. Then we'll talk about the effect of velocity and angle on range. And at the last, we'll talk about the effect of air resistance as well. Okay, so let's start. Let's go deep into this topic. Okay, so if we start with this projectile motion, let me put up a small question in front of you, that what will happen if I drop a ball from a certain height? Let's say this is the ball. Let's say this ball is at, for example, this is a building, let's say. And if you drop a ball from this certain height, we know that ball will go down and it will uh, fall in a downward direction. But let's say what will happen if I shoot this ball like this. So this is a drop motion and this is a short motion. So my question is, which ball will reach the ground first? So it's up to you. You can guess. Okay. So whatever comes to your mind, you can tell me. Uh, but generally, the intuition is that the red ball will reach the ground first. But let's see. Let's see this experiment first. What is actually happening in this experiment? So let's just wait for this video. Okay. So let me just make this uh, video a bit larger so that you can easily see this whole motion. Okay. So the one of the motion is a drop motion and the other one is a short motion. So this is a short motion, basically, like ball is coming, like this is a direct drop motion, and the velocity, the vertical acceleration, you can, sorry, the vertical acceleration of ball in this vertical drop is minus 9.8. Why it is negative? Because it is in a downward direction. Generally the trend is the convention, the sign convention that we follow is that anything which is going up or upward acceleration is taken as positive and downward acceleration is taken as negative. So that's why um, the acceleration of this ball, which is going down, is taken as negative. So now let's see which ball will reach the ground first. So now you can see both the balls they are actually, like, reaching the ground at the same time. Okay, they have same vertical motion because the acceleration of both the balls are same, which is minus 9.8 meter per second. Okay, so this is a very interesting thing. Okay, so if we try to explain, or if I if I try to write down the definition for you of the projectile motion, sorry, it will be uh, projectile motion projectile motion is a motion under gravity, is a two-dimensional motion under gravity. Motion under gravity. When I say two-dimensional motion, this means that the body is covering some distance along x-axis and also some distance along y-axis. Okay. Uh, if I give you some examples from daily life, for example, if you throw an arrow at the target, the path of arrow will be a sort of projectile because the arrow is covering some distance vertically and also some distance horizontally. Okay. Same example, if you throw a stone, let's say, of a building, so the stone will follow this path. Okay. So this is also a projectile. Okay. Let's say if you're interested in cricket like me, so uh, whenever a batsman hits a ball for a six, so the path of a ball is also a projectile because it is covering some distance along y-axis and also some distance along x-axis. Okay. And if you are interested in soccer, or if you are a fan of Ronaldo or Messi, so um, whenever someone kicks a football, let's say a goalkeeper, when he kicks a football in air, the path of football is also a projectile. Actually, this shape, this curved shape is known as parabola. Okay. So always remember the path of a projectile is parabola. So in a projectile, you actually launch something at certain angle, and the body will cover some distance along x-axis and some distance along y-axis. Let me show you a very interesting simulation uh, related to this projectile. But any question, any issue so far till now? Any issue, any question that you want to ask, or any query? Okay, so let's move on to this. It's a very interesting simulation on PHET website. You can just search this website and you can get this simulation. So I can change my angle, okay, uh, and I will shorts and will short different projectile. I can change speed from here, and basically now I want to see what is actually happening there. How different uh, parameters of motion, which are like velocity, like acceleration of force, how these parameters will behave. Okay. So whenever you want to study any motion in detail, you should have a good understanding of these parameters. Like for example, in any motion, whether it's a projectile or any other type of motion, you should know how velocity will behave in that motion, how acceleration will behave in that motion, how force will behave in that motion. Okay. So we will see these different parameters one by one. Okay. So let's say if I shot a projectile at angle of 55 degree, let's say. So let's see how velocity vector will behave. So uh, you can see uh, this is the horizontal one is a horizontal component of velocity. The vertical one is a vertical component or y component of velocity. You can see there is a difference between the vertical component, okay, of velocity, but the horizontal component of both the projectiles are same. Okay, so this means that the horizontal velocity of the projectile is not changing at all, but the vertical velocity is changing. So, like the more height the projectile will have, smaller its vertical velocity will be. Okay, if we continue this motion, you will see now you can see x component is still as it is, but the y component of the first projectile is very small, and eventually it will become zero. So now at this point, the vertical component is almost zero, but still projectile have x component velocity. Okay, and now there's a very interesting change that from this point onward, the direction of velocity will change. Initially, the vertical velocity was in upward direction, but now as the ball is coming downward, the direction of velocity, the vertical component of velocity will change and it will become downward. Okay, so the more the ball will be closer to the ground, higher will be its vertical velocity will be, but x component of velocity will remain same. So let's write down these all these points here. So about velocity, the first point is x component or horizontal component of velocity is constant and y component of velocity keeps on changing and becomes zero at maximum height. So these are the two points that we can get from the analysis of velocity vector in projectile motion. Now let's come to uh, the acceleration one. So you can see the y component is decreasing and now it is increasing again, and x component is totally same. Now let's see how acceleration will behave. We know that acceleration is basically change in velocity per unit time. There's a very, you can say, sort of misconception among students that they think uh, the greater the velocity we have, greater will be the acceleration. No, that's not the case. Acceleration is not linked with the velocity. Remember this thing. Acceleration is linked with a change in velocity. So the more change you have in velocity, the more acceleration you will have. Okay. So this means that if the acceleration is totally dependent on the change in velocity, so here there will be two components of acceleration as well. One will be the x component and other will be the y component. Now you can see x component of velocity is not changing. So this means that if something is not changing, if velocity is not changing, in that case, acceleration will be zero. Okay. So x component, we can assume from this thing that x component of acceleration will be zero. Of acceleration is zero because velocity is constant along x-axis. Okay. Now, if we talk about the y component, velocity is constantly changing along y-axis, which means body will have some acceleration along y-axis. So let's see uh, how acceleration will behave in y-axis. So let me clear that. Let's set an angle at 55 degree again. We will see acceleration now. Okay. So now you can see that there is a constant downward acceleration over this whole path. Let me shoot another projectile. So now you can see that this the vertical component of acceleration is not changing at all. And it is constantly pointing downward. Why? Because constantly gravity is acting on this projectile. Okay. So about vertical component, we can say uh, body will have, a projectile will have a constant value of y component of acceleration. And remember this thing, that its value will be minus 9.8 meter per second square. Again, why minus? Because it is pointing in a downward direction. Okay, and it's totally equal to the acceleration due to gravity. Okay, now we have to talk about the third parameter, which is about the force and how force will behave in this whole phenomena. So always remember this thing, that whenever there's an acceleration, there will be a force. Okay, and if acceleration is zero, force will be zero. If acceleration is non-zero, force will be non-zero. Okay, so if the acceleration along the x component or horizontal component of acceleration is zero, this means that the horizontal component of force is also zero. Okay, so from this assumption, we can say, from this understanding this concept, we can say x component of force is zero. And remember this thing, it is totally according to the Newton's first law that you will study in dynamics. Okay, in upcoming chapter, you will study Newton's first law of motion, uh, which totally state this thing, that if there is acceleration, there will be a net force. If there is zero acceleration, there will be a zero force. Net force will be zero on the object. So obviously, if uh, there's a constant y component of acceleration acting on a projectile, so this means uh, y component of force should also be constant, will be constant, and remember it is equal to the weight. Okay, and it is equal to weight. Let's see how this thing will how force will behave. So again, on the same pattern, you will see you can see that there's a force of gravity which is acting in a downward direction, and the length of an arrow is constant. So this, which actually shows that the net force acting on a projectile is constant. Okay. Any question, any issue in this analysis of velocity, acceleration, and force, you can ask. Okay. So um, now I want to go through these um, terms that I mentioned: range, maximum height, and time of flight. Okay. So first of all, let's talk about range. Range is a maximum horizontal distance covered by projectile. So like, let me write down all the definitions first, okay, and also the formula. As I mentioned, the time is short in this demo lecture, so I will not be able to prove these formulas, but in a regular lecture, in a regular class, we can prove these things. But here in a demo lecture, I don't have too much time to prove these things. I will just write down the formulas. So the formula for this range is u square sine 2 theta over g. U is basically the initial velocity. Theta is the angle. Okay, the launching angle, at which angle you're launching your projectile. The second thing is maximum height. This shows maximum vertical distance covered by a projectile. maximum vertical distance covered by a projectile. Okay. And the formula for this range, this maximum height is somehow you can say it is like the formula for range, which is u square sine square theta over g. So there's a difference that here we have sine 2 theta and here we have sine square theta. So you should be very careful with these two tools. In range, it is sine 2 theta. And in height, we have sine square theta. Okay. So, okay. Let's move on to the third parameter, which is time of flight. So time of flight is maximum time taken by projectile to complete its motion. To complete its motion. And the formula for time of flight is 2u sine theta over g. So these are the three formulas that you should understand, you should know um, in order to calculate range or maximum height or time of flight. Like if you see this one, at this point, you can figure out the maximum height, which is 11.08 meter for this projectile. Okay. If we want to calculate the range, it is, you can see 31.04 meter and the total time is 3.01 second. Okay. So you can figure out these three parameters very easily using um, uh, these three formulas. A very interesting thing. Let me pose a question for you. What do you think? Let's say if I want to throw a small stone, which is like of a mass of, for example, let's say a few grams, let's say 5 gram. If I want to throw a, a small stone of 5 gram at this angle, and if I calculate this time, range, and height for that projectile, and if I want to throw a large stone of, let's say, 10 kg or 20 kg at same angle with same initial velocity, what do you think? Which projectile will have greater height and which projectile will cover more horizontal distance? Like which projectile will have higher range and height values? What do you think? Like, does mass matter in this whole analysis or not? This is my question for you. What do you think? Hmm? Okay, so basically, if you see these three formulas, we don't have mass involved in these formulas at all. Okay, it's a very interesting thing, I would say, because the whole analysis depend on just two factors: initial velocity and your launching angle. Okay, and like if you have same initial velocity with same launching angle, if you throw a very smaller object, let's say of a few gram, and a very huge object of several kgs, they both will cover the same path. They will have same uh, height. They will have same time of flight. They will have same range as long as we are neglecting air resistance. Remember this thing. Right now we are talking about the case in which air resistance is neglected. Okay, so if air resistance is neglected, mass doesn't matter at all, and both the masses, both the objects will have same parameters like range, height, and time. Okay, so if you see this one, these are some of the parameters that we can discuss. Okay, but what will happen if I start changing the angles? As we discussed that height and range and these things depend on angle. So if I start changing angles, and you will see there's a very beautiful um, uh, uh, relation between the angles. Okay, if I take the angle of 70 degree, let's say, let me redo all these, remove all these launches, and let's start with 80 degree. So at the at the speed of, let's say, we can set it at 15 meter per second. The angle is 80. So the height of projectile, or the length of projectile will be, the range will be 7.84, and height will be 11.12. Okay. If I set an angle at uh, let's say 25 degree, let's see what will happen. Okay. Now range is 17.5 and height is 2.05. I can achieve same range at another angle as well. Let's see which one, this is very interesting. Like, you can change the angle, but you will get the same range. Okay. And that will be, let me check. It will be, I think, 65 degree. Let's check if it is if I'm right or wrong. You can bet on me that this projectile will reach this same spot or not. Let's see. Okay, so yes, I won that. I won this thing. Um, so basically, there are certain angles which are, you can say, sort of coupled. Okay. So 65 and 25, these two are the coupled angles. You can say you will get the same range at these two angles. You can get this coupled angle. For example, if one of the angles is 25, you can get this coupled angle by subtracting it from 90. Okay. If you subtract 25 from 90, you will get 65. So 65 and 25, these two are coupled angles. Let's see. If I make my angle 30 degree, my range is this one, which is uh, 19.86. I can get the same range at the coupled angle of 30 degree. How you can get the coupled angle? By subtracting 30 from 90, which is 60 degree. So now you are very confident. Okay, if this is 60, I will reach this spot. Okay, yes, you got it. Let's change the angle again. If it is, let's say, 35, you will reach this point. Now you should tell me what is the coupled angle of this one. So it's very easy. You can just subtract it from 90, and it will be uh, 55. Let me set it at 55. And yes, we got it again. So it's a very beautiful, like, you can see physics works. So at certain angles, you can achieve um, the same range. Okay. So the height will be different, obviously, but the range is same for different angles. Okay. Now, um, I want to mention this thing here as well, that range, height, and time does not depend on mass of projectile. Okay, so you should be very clear about this thing. Okay, so now let's discuss what will happen if you, like, if you double the speed and if you double the angle of range. So basically, if you see the formula of range, it is u square sine 2 theta over g. Okay. In case of like, if we neglect a resistance, in that case we can get the maximum range at the angle of maximum range we can get when sine of this 2 theta, this whole thing, if this is equal to 1. We know that the like the range, or the answer of sine lies from +1 and -1. It's between -1 and +1. The range of sine is -1 and +1. So we can get the maximum result if the sine to theta is +1. So this means that um, if you take sine inverse, on this side it will be sine inverse of 1. Sine inverse, you can just take your calculator. Sine inverse of 1 is basically 45 degree. Sorry, 90. Sine is 1 at 90 degree. I can divide 2 on both sides. So theta is 45. So at 45 degree, but remember, in case of if air resistance is 0. If air resistance is 0, in case of in ideal case, you will get maximum range at the angle of 45 degree. Okay, let's check if we are right or wrong. So if I set the angle at 45 degree, you will see we will get the maximum range. Okay, let's shoot 1, 2, 3, fire. Okay, and yes, we got the maximum range at the angle of 45 degree. Okay, so like this is one of the thing about the range. The other thing is if you keep on increasing the speed, you will get more range. That the value of range will increase because it is directly proportional to square of velocity. Okay, let's do this thing. For example, if I increase my speed to, let's say, 20 meter per second at same 45 degree. Let's say if my range increases or not, and yes, it's out of the park actually. So you can see like increasing the velocity, it caused like a huge change in range because range is proportional not only to velocity but a square of velocity. Okay, uh, let's see if I shot it at 17 meter per second. Now you can see the range is also greater than 15 meter per second. If I change the mass, let's say, if the mass is 10 kg, you can see we will get the same path because I told you mass is independent in this whole picture. Okay, so this is the basics about these parameters, range, height, and time. The last thing that I want to talk about is basically what will be the effect if we of air resistance on this whole picture. Like if we take into account the air resistance, how this whole picture will be affected. Basically, air resistance will cause decrease in the in range and height both. So if we take air resistance and if we shot the same projectile at 70 meter per second, previously it hit at this spot. The range previously when air resistance was 0, range is 29.45, sorry, 29.46, and height is 7.36 meter. But now if you take into account the resistance, air resistance, you can see now the range will decrease to 22 meter. Previously it was 29 meter. Okay. Height was 7.36 meter. Now it is 6.28 meter. Okay. So basically, if you take into account the air resistance, then uh, actually you will not get the same range or same height. The air resistance will make these things smaller. Okay. So if a shot of 5 kg projectile, you will get this one. Okay. So now in case of air resistance, mass also start playing its part. Okay, so remember, mass is independent as long as we are neglecting air resistance. Okay, if you take into account the air resistance, then mass will also start playing its part. So now the range is 18.24 and this height is 5.54. Okay, so let's solve one of the question from IBDP past paper. So this is the question that any question, any issue, like whatever we have studied, like talked about the velocity vectors, also the acceleration and force vector as well, and its component as well. We understand the key terms, range, maximum height, time of flight, and their formulas as well. We also talked about maximum height and range at different angle, and you can also uh, just plug in different values of u and theta in these formulas, and you can get height and range. And we will also calculate the height in this given question that we will solve right now. We will solve this after this thing. Okay, we have to predict the doubling of initial velocity and theta effect on the range. We also discussed this thing, and also um, the effect of air resistance. So these are all the learning objectives that we have covered in this demo lecture. At the last, let's solve this question, a sort of practice question from IBDP paper, past paper. So a boy throws a stone from the edge of a cliff at angle of 20 degree above a horizontal with speed of 27. So this is the angle that we will use, and this is the initial velocity u. Okay. The cliff is 50 meter above the sea. So this is 50 meter above the sea surface. We are launching it at a speed of 27 meter per second at angle of 20 degree. Okay. So air resistance is negligible and the height of a throw can be ignored. Okay. So calculate the maximum height. Okay. So this is basically our projectile. Let me show this thing. So basically this is our projectile motion till this one, till this point. Okay. And we have to cover like the rest of path is also a projectile, but right now in this question, we are interested in calculating this height right now. And then we will add this red height into this 50 meter per second. Sorry, into height of 50 meter, not 50 meter per second, sorry. So we have to calculate this red height basically. So if you see the formula, uh, like, okay, if you like, you can solve it directly by using the formula of height as well. And like, if you see, like, if you just think about this height is actually a distance in a vertical direction. Range is the distance in horizontal direction or along x-axis. Height is the distance along y-axis, basically. So we will be interested in the y component of velocity. Okay. So if we see this formula, that is u square sine square theta over g. Okay. So value of u here is 27 meter per second. Theta is basically 20 and g is 9.8. So you can just plug in the values. So 27 square into sine of 20 degree, and you have to take square of it divided by 9.8. You just have to take out your calculator and you can just easily solve this one. So 27 square. You should also solve it. Like, I want my students to solve this question. Let's see who can solve this one quickly. Okay. Um, so divided by 9.8, which is 7.1. Have you got the same result? Hmm? So this is the extra height above this 50 meter. Like, if you see this image, this is the 50-meter height. Oh, sorry. This 7.1 meter height is this one. This height is 7.10 meter. Okay. The rest of the height, like if you have to calculate the whole height, okay. So this additional 50 meter, you will add it into this 7.10 because we have to calculate the maximum height above the sea. Okay, this is the main thing. If the statement of question is like calculate the maximum height above the cliff, then it will be 7.10. If it is maximum height above the sea during the flight, then it will be like total height will be 50 plus 7.1, which will be 57.1 meters. Any question, any issue from your side? Okay, so that's all about this. There was a very brief introduction regarding this topic of projectile motion. And like we discussed, basically, first of all, we talked about the basics of the projectile, the difference between shot and drop, and why both shot and drop reaches the ground at the same time, because both are the motions under gravity. Okay. In both cases, the body have an acceleration of 9.8 meter per second. So that's the reason that the object, whether it is in shot or a drop motion, they both will reach at the ground at the same time. Then we discuss different daily life examples of projectile, and we also discussed uh, different parameter of motion like velocity, acceleration, and force, and how they will behave. X component of velocity remain constant, so that's why x component of acceleration is zero, and also force is zero. uh, y component of velocity constantly keep on changing. So at like the vertical component of acceleration is constant, which is 9.8, and y component of force is also constant, because acceleration is constant, so force is also constant. Then we discussed the key terms like range, maximum height, and time of flight. Range is a horizontal distance, basically. Maximum height is a vertical distance, maximum vertical distance, and the time of flight, like the time taken for the whole whole path to cover. Okay, the time taken by the body to cover the whole path. If air resistance is neglected, generally, like on your level, we used to like in DP physics, we usually don't take into account the air resistance, but you should understand that it's an ideal case in which mass don't play any part. Okay, only initial velocity and launching angle, these two things play their part. These are the important factor. But once you take into account the air resistance, then the mass also start to play its part. And in case of range, like we get maximum range at the angle of 45 degree. And also if you increase the velocity, it will um, like the initial velocity, the square of initial velocity is directly proportional to the range. So that's all about this topic, a brief introduction about this topic from my side. Hope you enjoyed the topic and you have you will understand the concept of this project animation. Thank you so much. See you. Bye bye.